Hi everyone, welcome back. So this time we're going to be talking about how you can add together several vectors. They're like, well, aren't we doing that? Well, you're doing two vectors. Let's talk about like 4, 5, 8, 1,000. No, in this class, 1,000 vectors is not going to happen. However, you might get 3 or 4 that you're going to have to work with. Now, when you get to 3 or 4 vectors, I'm just going to be super honest with you, it's not a good idea to try to use the parallelogram method. You can use it for 2 vectors, make one resultant vector. You take that one, you add another vector to it, and you just keep on going. It can work. Sometimes it's the easiest way to do things. It's just very rare for that to be the case. Most commonly, what you're going to do is you're going to break everything up into its components. So you take force 1 here, force 3, force 2, and you break them up into force 1y and force 1x, force 2y and force 2x, force 3y and force 3x. And you can add together all of the x components, and that's one component of your resultant vector. And you can add together all the y components, and that's the second component of the resultant vector. And then you'll have it. It's a pretty simple process. It works every single time. You use the same trig functions over and over again. You just get used to it. It's very easy to understand. So, just like I said, add them all together, and then if you want to, you can find the magnitude and angle of the resultant vector. Now, how do you do that? It's not too terribly difficult. But we'll get to that at the end. I got one more slide first, and we'll talk about that. So first off, this is what it's going to look like. We have our 3 forces here. We have broken them up into components. If I want to get my resultant force, I just take all the x components and I add them together. All the y components and I add them together. Being very careful of direction. You see how F2y and F1y are both going up. F3y is going down. F1x and F3x are going to the right. F2x is going to the left. So you have to choose which direction is positive. Usually what we do is we'll put some sort of little symbol on our documents that say, certain directions are positive, like up and right. That's usually how it is. And when we do that, we add them all together, and this is the I component, or the component in the horizontal direction of our resultant vector, and this would be the y component. Okay, so we break them up. We look at all the different components, see how these are all I. I'm getting way too many circles here. Let me erase those. Put all the I components together, and then all of the j components together. And we have a resultant vector. Okay, now how to get the angle? It's all just your trig. So we know that the length of this side is going to be equal to FRY, and the length of this side is FRX. And what you typically do is you just use your inverse tan function. Opposite over adjacent is equal to tan. You can also, if you wanted to, use sine or cosine, you'd be using your resultant vector. And if you don't necessarily need to know that, why do an extra step? To get the magnitude of a resultant vector, we'd use Pythagorean theorem. The whole a squared plus b squared, a squared plus b squared is equal to c squared thing. That's what we're doing right here. That is Pythagorean theorem. And that gives us the length of the hypotenuse of our triangle. So if you already know this, you could use sine or cosine instead of tan here. But we don't need to. It works. Okay, so when we come back next time, we'll actually start breaking up some examples of this using both the parallelogram method as well as breaking everything up into components and showing the benefits of each. So, hope you enjoyed this, and I'll see all of you next time. Bye-bye.